Hello, legacy students, and today we're going to look at the second part of Unit 3 on compound inequalities. So today we're going to look at the AND inequalities. You're going to want to have your notebook, pen or a pencil, and then you're also going to want a calculator today. Your learning goals for this particular video: I can solve compound inequalities containing and then also you can graph a compound inequality containing and. So, just remember, a compound inequality basically is two distinct inequalities joined together by the words and or the word or. Today we're just going to look at the and inequality since we already looked at ors already. So, very first thing, this is what an and inequality may look like. Basically, it looks like two inequalities slapped together to make one big granddaddy inequality. So, don't be afraid of it though, because there's two inequality symbols hanging around. Basically, all you're going to do is you're going to do it to every single area. So here is one area, and here is one area. So I would have -3 is less than or equal to m minus 4, which is less than -1. Now, what if we forgot about this less than -1? And you would have had -3 is less than or equal to m minus 4. What would you have done? You would have added 4, right? But since this is an and inequality, you would add 4 here. But don't forget, you also have to add 4 over there. So it's basically you're going to do it twice because there's two sides to our inequality. And there's also the middle side, inside, where we're actually solving. So, let's see here. -3 plus 4 is 1. I'm going to keep my sign. Left with m. Keep the sign. -1 plus 4 is 3. So I have my inequality solved because m is alone. So I have 1 is less than or equal to m, which is also less than 3. So let's put our numbers on our inequality line. So I have 1 and 3. It looks like I'm going to have a closed dot at 1, right? And an open dot at 3. Now, this is where a lot of students kind of get confused where to graph. So let's read from the variable. M is greater than or equal to 1. Notice how I'm reading backwards from the sign. Because if we would flip-flop that front part, I'd have M is greater than or equal to 1, right? Because the bigger part's pointing to the M. So, M has to be bigger than 1. So we're going to go on this side of the inequality sign. Now, let's shade in this one. M is less than 3. So to be less than 3, we're going to be going this way. Do you see how my two lines are in the middle? That's actually where my answer is. So, if I erase my two scribbles there, and with purple, I'm going to actually be in the middle of the two dots. So, kind of like how or went away from each other because it's either or. Well, and is in the middle. We're including everything because it's an and inequality. It's conjoining the two together. Let's try a second problem. I have -3 is less than or equal to -6m less than 6. So, what are we going to do with that -6 times m? Well, we got to undo -6, right? Get rid of it. So the inverse operation of multiplication is division. So we're going to divide by -6 on both sides. -3 divided by -6. Well, that's just a half, right? Simplified down. What did you? Oh, I divided by a negative. Thanks for reminding me. So, since I divided by a negative, got to flip the inequality sign. -6's are going to cancel out. I'm left with m. And then I'm going to have, flip the inequality sign. Because I flipped that one, I got to flip this one too. So don't forget about flipping multiple. 6 divided by -6 is -1. So now, let's graph. I have -1 and I have a half. Let's see if they go together just like the first one. So let's flip this around here, flip-flop. So m is less than or equal to 1/2. So to be, I forgot about the dots. Jumped ahead of myself. Holy buckets. So, right there's closed, open over here, right? Now, let's shade. m is less than or equal to 1/2. Well, less than or equal to would be this way. Let's see. Does negative 1 go that way? M is greater than negative 1. Well, m is greater than negative 1 on the right. Notice how they're going in between the two. Just like ors, they always went outwards, and 90% of the time will go inwards. That's always going to happen, which is a wonderful thing. It's about 90% of the time that it does happen that way. The other 10%, they go away from each other, or they do something silly. That is something that happens. Most of the time, though, you're going to see that they're going to go together. But to be careful, always make sure you read through the problem and check that they should go together. Let's try a little harder of a problem. Notice now how it's separated by the word actually and. Now, notice though how this and this are exactly the same thing. Right? 3y minus 4. What you can do is join these two and make them into what we've been looking at already. So I can actually make this problem to this. So basically, took this piece and put this piece together with the piece that they both interlocked with. Makes sense, right? So now I can solve like I was before. Let's add 4 to both sides of my inequality there. Cancels out in the middle. And we left with 2 is less than 3y, which is less than 18. Let's divide by 3. 2 divided by 3 is 0.6 repeating. I'm just going to leave it as 2/3. 3's are going to cancel out, left with y in the middle. And 18 divided by 3 is 6. 18 divided by 3 is 6. So now, let's graph our line. I have 2/3 here and 6 over there. Looks like I have both open dots. Now, let's look. So if I rewrite that, y is greater than 2/3. So greater than goes this way. Less than 6 goes that way. So they're bouncing in the middle. Whew. Perfect. No worries there. Let's take a look at the last problem here. So I have negative 3 is less than or equal to 6 minus q divided by 9 is less than or equal to 3. So I need to get that division by 9 away. So let's multiply both sides by 9. Cancels out there. Negative 27 is less than or equal to 6 minus q, which is less than or equal to 27. Now, the 6. Let's get him out. So, that's a positive 6. So we need to subtract 6 on all sides. We will get a negative 33 over here, less than or equal to, whoop, there's a negative with that q. And 21, 27 minus 6 is 21. Now I have that negative. Now, that's technically a negative 1. So we need to divide everybody by negative 1. Negative 33, divided by negative 1 is a positive 33. Gotta flip my inequality sign. Divided by a negative. Almost forgot about it again. Let's flip the inequality sign. Got a q here. And let's flip the inequality sign. So I got negative 21, right? Because q, yeah, it was a positive. So let's graph our two lines. Negative 21, 33. Looks like they're both closed dots. There we go. Q is less than or equal to 33. So less than 33 will go that way. And Q is greater than negative 21, which is that way. Wonderful. They go inside, just like a normal and would. Let's look at a story problem. So your test scores in science are an 83 and 87. What possible scores can you earn in your next test to have a test average between 85 and 90 inclusive? So now, let's do a little bit of test in your mind. How do you find the average of scores? It's also known as a mean. We add it all up and divide by how many there are, right? So we already have a test of 83, a test of 87, and we have a next test. So let's call that X. That's 3 tests, so we're going to divide by the number there are, which is 3. And I want to know between 85 and 90 inclusive. Inclusive means we're going to include it. So we're going to include 85. So 85 is the smallest part we want. But we want to be bigger than 85, but smaller than 90, right? So let's start solving here. 83 plus 87, I know that's 170. So let's cross that out and make that 170. Multiply by 3 on both sides. Let's get rid of that division by 3. 85 times 3 is 255. I get 170 plus X. 90 times 3 is 270. Let's subtract 170 here. 255 minus 170 is 85. Cancels out to 0, left with my X and 100. So, to get a between 85 and 90% on your tests for average, you need to get on your next test between an 85 and a 100% on your next science test. Pretty cool that you can figure that out, huh? And that's the end of this video. See you later, Savers!